Inter-process communication using shared memory requires communicating processes to establish a region of shared memory. Processes that wish to communicate using shared memory segment must attach it to their address space. In this session, we'll be seeing an example where one process sends two numbers to another process using the shared memory, and the second process calculates the sum of these two numbers. For this, we will be creating a shared memory segment, then attaching it to the first process. Then first process writes these two numbers to the shared memory segment, and the second process attaches the shared memory segment to it and reads these two numbers and calculates the sum. So we will be creating two programs, one for sending two numbers, and we will be creating another program called receiver that reads these two numbers and calculates the sum. So our first program is called sender.c. We will be including the required header files. Then what we will be doing first is we will be creating a shared memory object. So you can use a function shm_open to create a shared memory object. The first argument is name to the name of the shared memory. Usually it should be preceded with a slash for portability. In Linux systems, you can also give the name without giving the slash. Here I am giving the name as OS Lab. The name of our shared memory is OS Lab. Then we need to give the flags. Since we are trying to create the shared memory, we will be giving the flags as create and read write. So this can be given by ORing the create and create or o_rdwr. And next we need to give the mode. What we will be giving is we will be giving a read write permission for the user group and others. So you can give 0666. 0666 means read write permission for user group and others. What this shm_open returns is a file descriptor, which is an integer value. So you can assign like this. You should define an integer in the fd. So after this, you need to set the size of the shared memory just created. For this, you can use the function ftruncate. First argument is the file descriptor, which is returned by shm_open. The second argument is the size, the size to which we need to limit the shared memory. So here we just need to store two integer values. So we just need to limit it to what we will be doing here is we will be limiting it to the size of two integers. So you can give it like 2 times size of int. So if you know the size of integer in your particular supported by the particular compiler, you can just give that. Otherwise you can give size of int. Next we will map the shared memory region to the address space of the process. For that we will be using the function mmap. So we will see how to do that. Mmap. The first argument is the address to which mapped. So if you give the null, the argument as null, then the place to which the mapping to be done will be decided by the kernel. So will be giving null. Then we need to define the size of the mapping. Since we are mapping two integers, so like we done above, we can give 2 star size of int. That is a second argument, that is the size. Then the third argument is the protection. So protection of the mapped area. So since we need to allow read and write, we can give, they are predefined values, predefined constants. Prot underscore read, they can be odd, or prot underscore write, prot underscore write. And the next argument specifies how the mapped area to be treated, whether it needs to be shared, whether it is private. So here we are allowing it to be shared between different processes. So we write map underscore shared. This is another predefined constant. You can see the different values, possible values, by going to the man page. You can type man space mmap. So see the possible values. And the next argument is the name of the shared memory. The file, you can give the file descriptor returned by shm underscore open, that is fd. And the last one is offset. So we can give the value as 0, offset value as 0. So what this mmap returns is void star. Mmap returns a void star. So since the value we are writing are integers, we are casting it to int star. So you can write int star, and we are storing it in an integer pointer data. Int star data equal to, we can write int star data equal to int star of mmap. So what this does is it creates a mapping to the address space of the process. That is, the program is sender.c. So now we have created the mapping to the process. Next we will be reading two numbers and storing it in the shared memory area. So we are taking the values from the user. So you can use the scanf function. Scanf, since we are taking the integer values, scanf %d. We will be using the two numbers, two variables, num1 and num2. So scanf %d address of num1. Then we will be storing it in the data, that is the shared memory region that is mapped. Data of 0 is num1. Then again we will be doing the same thing, scanf %d address of num2, data of 1 equal to num2. So you need to create two variables, integer variables, num1 and num2. So after doing all these things, what you can do is you can unmap the region so that the shared region will be there, but it is unmapped from the current process. So the function that should be used is munmap. Argument is the region, that is data. The data is a pointer in the process where the mapping is done, and the size, again 2 star size of int. So we have unmapped the data from the shared memory fd from the process area, that is data. Then after this you can close the file descriptor, close fd, like what we did when writing to a file. Then return 0. So this completes our program that sends or writes two integers to a shared memory region. Next we will see how to run this program. So we can compile this program by typing ECC sender.c. We will be creating the object file as sender. So I will be using the option -o. Then for compiling you need to link it by typing -lrt option. So this will create a file called sender. So if you run this, then this will create shared memory by the name OSLab, and the program will ask for two numbers, and when you give these two numbers, that will be stored in the shared memory called OSLab. So let's see what happens if you run this. You can give the two numbers. I will be giving the number 2 and 3. And then after running this, what happens is this will be stored in the shared memory. So this shared memory is actually a file. You can see this in Unix based system in the directory /dev/shm. So you can, if you run this, I am using the ls command. You can see that there is a file called OSLab. This is the file, this is a shared memory where we will be storing the data. So we have created a shared memory, and we have written some data to that. Now we will create some other program. What that program does is, that program will attach the already created shared memory to its own address space, then read these two numbers and calculates the sum. So let's see how to do that. So we will be creating other program. We will be naming it receiver.c. For opening the shared memory, we need to use the shm open function, just like what we did in the last program. shm_open. Like the last program, the first argument is the name of the shared memory region, that is OSLab, which we already created. Then we need to give the mode. Since we are not creating the shared memory, we just need to read the values. So we will be giving O_RD only. Then we will be giving the flag 0666. So we have opened the shared memory. Then we will be using the mmap function for mapping. This we have already seen this, so I will be just copying this. So the arguments are same like last time. This is for attaching the shared memory to the address space of the process. The second program is receiver. So here you can see that we haven't used ftruncate. There is no need for ftruncate since the shared memory is already there. We need to, after opening, we just need to attach it to the address space of the new process. So after this, what you can do is you can read the values. So first, before calculating the sum, just see whether the values are there. So we are printing the values. The pointer is data. For data of 0, will print the first number, and data of 1 will print the next number. So after having this, it's good to unmap. So you can use unmap data 2* size of int. Then close the file descriptor. Next we will see how to run this. So we can compile by typing receiver.c -o receiver minus LRT. You can link it by typing option minus LRT. So this will create a file called receiver. So you can run this. So if you run this, this will print the values. So you can see that the values 2 and 3 are printed, which we already written to the shared memory in the last program. So for creating the sum, you can modify it as print data 0 plus data 1. So if our use is over, you can also unlink the shared memory region by using the function shm_unlink. This will remove the shared memory region which we just created. So you can give OS lab. So this will also remove the shared memory. So if you run this program, this will print the sum and the shared memory will be removed. So you can see that the sum is printed. So if you see whether shared memory exists, if you type ls, you can see that there is no file in shared memory. So we have removed that using shm_.